The systems development lifecycle, also referred to as the application development lifecycle, is a term used in systems engineering, information systems and software engineering to describe a process for planning, creating, testing, and deploying an information system. The systems development lifecycle concept applies to a range of hardware and software configurations, as a system can be composed of hardware only, software only, or a combination of both. Overview. A systems development lifecycle is composed of a number of clearly defined and distinct work phases which are used by systems engineers and systems developers to plan for, design, build, test, and deliver information systems. Like anything that is manufactured on an assembly line, an SDLC aims to produce high-quality systems that meet or exceed customer expectations based on customer requirements, by delivering systems which move through each clearly defined phase, within scheduled timeframes and cost estimates. Computer systems are complex and often link multiple traditional systems potentially supplied by different software vendors. To manage this level of complexity, a number of SDLC models or methodologies have been created, such as waterfall, spiral, agile software development, rapid prototyping, incremental, and synchronize and stabilize. SDLC can be described along a spectrum of agile to iterative to sequential. Agile methodologies, such as XP and Scrum, focus on lightweight processes which allow for rapid changes along the development cycle. Iterative methodologies, such as Rational Unified Process and Dynamic Systems Development Method, focus on limited project scope and expanding or improving products by multiple iterations. Sequential or big design upfront models, such as waterfall, focus on complete and correct planning to guide large projects and risks to successful and predictable results. Other models, such as anamorphic development, tend to focus on a form of development that is guided by project scope and adaptive iterations of feature development. In project management, a project can be defined both with a project lifecycle and an SDLC, during which slightly different activities occur. According to Taylor, the project lifecycle encompasses all the activities of the project, while the systems development lifecycle focuses on realizing the product requirements. SDLC is used during the development of an IT project. It describes the different stages involved in the project from the drawing board through the completion of the project. History. The product life cycle describes the process for building information systems in a very deliberate, structured and methodical way, reiterating each stage of the product's life. The systems development lifecycle, according to Elliott and Strachan and Radford, originated in the 1960s to develop large-scale functional business systems in an age of large-scale business conglomerates. Information systems activities revolved around heavy data processing and number crunching routines. Several systems development frameworks have been partly based on SDLC, such as the Structured Systems Analysis and Design method produced for the UK Government Office of Government Commerce in the 1980s. Ever since, according to Elliott, the traditional lifecycle approaches to systems development have been increasingly replaced with alternative approaches and frameworks, which attempted to overcome some of the inherent deficiencies of the traditional SDLC phases. The system development lifecycle framework provides a sequence of activities for system designers and developers to follow. It consists of a set of steps or phases in which each phase of the SDLC uses the results of the previous one. The SDLC adheres to important phases that are essential for developers, such as planning, analysis, design, and implementation, and are explained in the section below. It includes evaluation of present system, information gathering, feasibility study and request approval. A number of SDLC models have been created: waterfall, fountain, spiral, build and fix, rapid prototyping, incremental, and synchronize and stabilize. The oldest of these, and the best known, is the waterfall model, a sequence of stages in which the output of each stage becomes the input for the next. These stages can be characterized and divided up in different ways, including the following. Preliminary analysis. The objective of Phase 1 is to conduct a preliminary analysis, propose alternative solutions, describe costs and benefits, and submit a preliminary plan with recommendations. Conduct the preliminary analysis. In this step, you need to find out the organization's objectives and the nature and scope of the problem under study. Even if a problem refers only to a small segment of the organization itself, then you need to find out what the objectives of the organization itself are. Then you need to see how the problem being studied fits in with them. Propose alternative solutions. In digging into the organization's objectives and specific problems, you may have already covered some solutions. Alternate proposals may come from interviewing employees, clients, suppliers, and/or consultants. You can also study what competitors are doing. With this data, you will have three choices. Leave the system as is, improve it, or develop a new system. Describe the costs and benefits. Systems analysis. Requirements definition. Defines project goals into defined functions and operation of the intended application. It is the process of gathering and interpreting facts, diagnosing problems and recommending improvements to the system. Analyzes end-user information needs and also removes any inconsistencies and incompleteness in these requirements. A series of steps followed by the developer are: collection of facts. End-user requirements are obtained through documentation, client interviews, observation and questionnaires. Scrutiny of the existing system. Identify pros and cons of the current system in place, so as to carry forward the pros and avoid the cons in the new system. Analyzing the proposed system. Solutions to the shortcomings in Step 2 are found, and any specific user proposals are used to prepare the specifications. Systems design. Development. The real code is written here. Integration and testing. Brings all the pieces together into a special testing environment, then checks for errors, bugs and interoperability. Acceptance. Installation. Deployment. The final stage of initial development, where the software is put into production and runs actual business. Maintenance. During the maintenance stage of the SDLC, the system is assessed to ensure it does not become obsolete. This is also where changes are made to initial software. It involves continuous evaluation of the system in terms of its performance. Evaluation. Some companies do not view this as an official stage of the SDLC, while others consider it to be an extension of the maintenance stage, and may be referred to in some circles as post-implementation review. This is where the system that was developed, as well as the entire process, is evaluated. Some of the questions that need to be answered include: does the newly implemented system meet the initial business requirements and objectives? Is the system reliable and fault-tolerant? Does the system function according to the approved functional requirements? In addition to evaluating the software that was released, it is important to assess the effectiveness of the development process. If there are any aspects of the entire process, or certain stages, that management is not satisfied with, this is the time to improve. Evaluation and assessment is a difficult issue. However, the company must reflect on the process and address weaknesses. Disposal. In this phase, plans are developed for discarding system information, hardware and software in making the transition to a new system. The purpose here is to properly move, archive, discard or destroy information, hardware and software that is being replaced, in a manner that prevents any possibility of unauthorized disclosure of sensitive data. The disposal activities ensure proper migration to a new system. Particular emphasis is given to proper preservation and archival of data processed by the previous system. All of this should be done in accordance with the organization's security requirements. In the following example, these stages of the system's development life cycle are divided in 10 steps from definition to creation and modification of IT work products. Not every project will require that the phases be sequentially executed. However, the phases are interdependent. Depending upon the size and complexity of the project, phases may be combined or may overlap. System investigation. The system investigates the IT proposal. During this step, we must consider all current priorities that would be affected and how they should be handled. Before any system planning is done, a feasibility study should be conducted to determine if creating a new or improved system is a viable solution. This will help to determine the costs, benefits, resource requirements, and specific user needs required for completion. The development process can only continue once management approves of the recommendations from the feasibility study. Following are different components of the feasibility study: operational feasibility, economic feasibility, technical feasibility, human factors feasibility, legal, political feasibility. System analysis. The goal of system analysis is to determine where the problem is, in an attempt to fix the system. This step involves breaking down the system in different pieces to analyze the situation, analyzing project goals, breaking down what needs to be created, and attempting to engage users so that definite requirements can be defined. Design in systems design. The design functions and operations are described in detail, including screen layouts, business rules, process diagrams, and other documentation. The output of this stage will describe the new system as a collection of modules or subsystems. The design stage takes as its initial input the requirements identified in the approved requirements document. For each requirement, a set of one or more design elements will be produced as a result of interviews, workshops, and/or prototype efforts. Design elements describe the desired system features in detail, and generally include functional hierarchy diagrams, screen layout diagrams, tables of business rules, business process diagrams, pseudocode, and a complete entity relationship diagram with a full data dictionary. These design elements are intended to describe the system in sufficient detail, such that skilled developers and engineers may develop and deliver the system with minimal additional input. Design environments. Environments are controlled areas where systems developers can build, distribute, install, configure, test, and execute systems that move through the SDLC. Each environment is aligned with different areas of the SDLC and is intended to have specific purposes. Examples of such environments include the development environment, where developers can work independently of each other before trying to merge their work with the work of others. Common build environment, where merged work can be built together as a combined system. User acceptance testing environment, where business stakeholders can test against their original business requirements. Production environment, where systems finally get deployed for final use by their intended end users. Testing. The code is tested at various levels in software testing. Unit, system, and user acceptance testings are often performed. This is a gray area as many different opinions exist as to what the stages of testing are and how much, if any, iteration occurs. Iteration is not generally part of the waterfall model, but the means to rectify defects and validate fixes prior to deployment is incorporated into this phase. The following are types of testing that may be relevant, depending on the type of system under development. Defect testing. The failed scenarios, including defect tracking, path testing, dataset testing, unit testing, system testing, integration testing, black box testing, white box testing, regression testing, automation testing, user acceptance testing, software performance testing, training and transition. Once a system has been stabilized through adequate testing, the SDLC ensures that proper training on the system is performed or documented before transitioning the system to its support staff and end users. Training usually covers operational training for those people who will be responsible for supporting the system, as well as training for those end users who will be using the system after its delivery to a production operating environment. After training has been successfully completed, systems engineers and developers transition the system to its final production environment, where it is intended to be used by its end users and supported by its support and operations staff. Operations and maintenance. The deployment of the system includes changes and enhancements before the decommissioning or sunset of the system. Maintaining the system is an important aspect of SDLC, as key personnel change positions in the organization. New changes will be implemented. There are two approaches to system development. There is the traditional approach in object-oriented. Information engineering includes the traditional system approach, which is also called the structured analysis and design technique. The object-oriented approach views the information system as a collection of objects that are integrated with each other to make a full and complete information system. Evaluation. The final phase of the SDLC is to measure the effectiveness of the system and evaluate potential enhancements. Systems analysis and design. The systems analysis and design is the process of developing information systems that effectively use hardware, software, data, processes, and people to support the company's business's objectives. System analysis and design can be considered the meta-development activity, which serves to set the stage and bound the problem. SAD can be leveraged to set the correct balance among competing high-level requirements in the functional and non-functional analysis domains. System analysis and design interacts strongly with distributed enterprise architecture, enterprise IT architecture, and business architecture, and relies heavily on concepts such as partitioning, interfaces, personae and roles, and deployment, operational modeling to arrive at a high-level system description. This high-level description is then further broken down into the components and modules which can be analyzed, designed, and constructed separately and integrated to accomplish the business goal. SDLC and SAD are cornerstones of full life cycle product and system planning. Object-oriented analysis. Object-oriented analysis is the process of analyzing a task to develop a conceptual model that can then be used to complete the task. A typical OOA model would describe computer software that could be used to satisfy a set of customer-defined requirements. During the analysis phase of problem solving, a programmer might consider a written requirements statement, a formal vision document, or interviews with stakeholders or other interested parties. The task to be addressed might be divided into several subtasks, each representing a different business, technological, or other areas of interest. Each subtask would be analyzed separately. Implementation constraints are not considered during the analysis phase, rather, they are addressed during object-oriented design. The conceptual model that results from OOA will typically consist of a set of use cases, one or more UML class diagrams, and a number of interaction diagrams. It may also include some kind of user interface mockup. The input for object-oriented design is provided by the output of object-oriented analysis. Realize that an output artifact does not need to be completely developed to serve as input of object-oriented design. Analysis and design may occur in parallel, and in practice, the results of one activity can feed the other in a short feedback cycle through an iterative process. Both analysis and design can be performed incrementally, and the artifacts can be continuously grown instead of completely developed in one shot. Some typical input artifacts for object-oriented conceptual model. Conceptual model is the result of object-oriented analysis. It captures concepts in the problem domain. The conceptual model is explicitly chosen to be independent of implementation details, such as concurrency or data storage. Use case. Use case is a description of sequences of events that, taken together, lead to a system doing something useful. Each use case provides one or more scenarios that convey how the system should interact with the users called actors to achieve a specific business goal or function. Use case actors may be end users or other systems. In many circumstances, use cases are further elaborated into use case diagrams. Use case diagrams are used to identify the actor and the processes they perform. System sequence diagram. System sequence diagram is a picture that shows, for a particular scenario of a use case, the events that external actors generate, their order, and possible inter-system events. User interface documentations. Document that shows and describes the look and feel of the end product's user interface. It is not mandatory to have this, but it helps to visualize the end product and therefore helps the designer. Relational data model. A data model is an abstract model that describes how data is represented and used. If an object database is not used, the relational data model should usually be created before the design. Since the strategy chosen for object relational mapping is an output of the OO design process, however, it is possible to develop the relational data model and the object-oriented design artifacts in parallel, and the growth of an artifact can stimulate the refinement of other artifacts.